For years, astronomers have dreamed of seeing another world the way we see our own, clearly, directly, and undeniably real. Not as a blurred signal, a distant shadow, or a simulation stitched together from data, but as an actual image of a planet orbiting another star. A world with its own sky, its own atmosphere, and its own story. Now, for the first time in human history, the James Webb Space Telescope has done exactly that. It has captured the first real image of another world, a world that shouldn't exist where it is, a world stranger than anything we imagined, and a world that is already rewriting the rules of planetary science. But that image was only the beginning. As the James Webb Space Telescope continued observing, it uncovered something even more astonishing: planets with impossible chemistry, mysterious atmospheres, broken rules of formation, and one world that may hold the strongest hints of alien life ever detected. Tonight, we step into that first image and follow the trail of discoveries it unleashed. K2-18b was never meant to become the center of global scientific debate. At first, it was simply another distant super-Earth, too large, too far away, and too difficult to study with the instruments available at the time. But when Webb turned its gaze toward the planet, the telescope did more than collect data. It peeled back the atmosphere itself. Layer by layer, molecule by molecule, the James Webb Space Telescope revealed a world wrapped in a dense envelope of hydrogen, beneath which may lie something extraordinary, a global ocean deep enough to swallow entire mountain ranges. Water vapor appeared immediately, strong and unmistakable. What came next pushed the planet into scientific history. Webb detected methane, carbon dioxide, and then the molecule that sent shock waves through observatories around the world, dimethyl sulfide, a chemical that on Earth is produced almost exclusively by life in our oceans. This was not noise or distortion. The signal repeated across multiple observations. Suddenly, the idea of a dark, endless alien ocean no longer seemed like science fiction. It seemed possible. Scientists began imagining a world where sunlight filters weakly through a thick atmosphere, warming the boundary between day and night into a stable, habitable twilight. A world where life, if it exists, could emerge slowly and silently, forming ecosystems unlike anything on Earth while still obeying the same universal laws of chemistry. Researchers were cautious, but they could not ignore the implications. If any planet humanity has ever studied has the potential to host life, K2-18b may be the strongest candidate yet. When Webb captured the first real image of HIP 65426b, astronomers expected to find a typical gas giant, massive, distant, and predictable. Instead, the image revealed something far stranger. HIP 65426b is an enormous planet nearly 7 times the mass of Jupiter, orbiting so far from its parent star that, according to current theories, it should not exist there at all. Every major model of planetary formation suggests that giant planets must form within the swirling disk of gas and dust surrounding a young star. Yet this world sits far beyond that region, isolated in the darkness, as though it formed somewhere else entirely before arriving in its present orbit. The mystery deepened when the James Webb Space Telescope analyzed the planet's light. Instead of the smooth atmospheric profile expected from a gas giant, HIP 65426b displayed unusual chemical layers, unexpected temperature variations, and cloud structures that appeared remarkably unstable. Its atmosphere did not behave like that of a planet quietly evolving around its star. It behaved like something disturbed, something that had experienced violent changes or traveled through very different environments before reaching its current position. These findings led scientists to consider ideas that once seemed almost impossible. Perhaps the planet was ejected from another star system during a chaotic gravitational encounter before being captured by its current host star. Or perhaps it formed alone in the cold darkness of interstellar space as a rogue planet, wandering for millions of years until gravity finally pulled it into orbit. The most intriguing possibility, however, is the one many astronomers discuss quietly. Perhaps HIP 65426b is not merely an anomaly, but a clue, a sign that planetary systems can form in ways we have never imagined. That planets may migrate across enormous distances, and that the universe is capable of assembling worlds through mechanisms we have only begun to explore. Webb's first true portrait of an exoplanet was not simply proof that other worlds exist. It was a message. These worlds are stranger than anyone expected, and the discoveries that followed would only deepen the mystery. Proxima b has often been described as the most tempting planet in the galaxy. Located just over 4 light-years away, it orbits within the habitable zone of Proxima Centauri, the closest star to our Sun. From the moment it was discovered, astronomers imagined vast oceans, protective atmospheres, and perhaps even the faint outlines of continents hidden beneath alien clouds. It seemed to represent everything humanity hoped to find in an exoplanet, a nearby rocky world with temperatures suitable for liquid water. But when the James Webb Space Telescope turned its attention toward this neighboring planet, excitement quickly gave way to frustration. Proxima b orbits so close to its star that it disappears into the overwhelming glare. Its atmosphere cannot be observed directly because Webb cannot separate the faint light reflected by the planet from the intense radiation pouring from its parent star. As a result, we know the planet exists, yet we still cannot truly see it. Then an even deeper problem became clear. Proxima Centauri is not a peaceful star. It is a highly active red dwarf that regularly unleashes enormous solar flares, bursts of radiation powerful enough to strip away a planet's atmosphere over geological timescales. If Proxima b once possessed oceans or a breathable atmosphere, they may have been blasted away long ago. Even more troubling, the planet may be tidally locked, with one side permanently facing its star, while the other remains in eternal darkness. In that case, any habitable region might exist only within a narrow twilight band between the scorching day side and the frozen night side.